great seeing you here again. My name is Luc de Custer, founder of the Custer Academy. And in this new video, we're going to talk about the calculation of the internal rate of return using Excel and its built-in formulas. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look at how this works. Let's look at a simple exercise. We have an initial investment, CF0, which is 55K. I put a minus there because we have the cost, which is important to consider. Then in the second row, CF1, the first year cash flow, 25K, the second year 20K, and the last year 15K. We have those three elements, and based on this, we're going to calculate the internal rate of return of those three cash flows compared to the initial investment. But don't forget, I'm sure you remember, but I will write it down again, the NPV formula and how we find the internal rate of return. The NPV formula is in fact the sum for I, 1, 2, in our case, the CFI divided by 1 plus the internal rate of return to the power I plus CF0. We have a negative sign here, so we have to add it, and this has to be equal to 0. We are going to calculate this for different percentages. Let's say the first percentage we consider, our first guess, is 4%. So this means that we are going to calculate this sum. So we have 25 divided by 1 plus 0.04 to the first power, plus 20 divided by 1 plus 0.04 to the second power, plus 15 divided by 1 plus 0.04 to the third power, and we subtract here 55K. When we calculate this, this will be approximately equal to 0.9K. This is positive, larger than 0, so we still don't have the internal rate of return, but we're very close to 0. So we can assume that the internal rate of return will be close to 4%. We do the same now for a second estimate. Let's say we take 6%. So we have the same numbers here, but we have 25 divided by 1 plus 0.06 to the first power, plus 20 divided by 1 plus 0.06 to the second power, plus 15 divided by 1 plus 0.06 to the third power, and here we subtract the 55K. And we see that this is approximately equal to minus 1.0K, which means this is negative. So we can say, we can conclude here that the internal rate of return is between 4 and 6%. This we can repeat, we can find additional estimations of the internal rate of return, and we find that the internal rate of return will be somewhere between those two. Now, when we use the formulas in Excel, we can use the formula, the IRR, and we use the cash flows. In this case, we have the cash flows like we have the rows and the columns. So we have B1 till B4, and then we have a guess, and we can say this will be 4%. Our first guess would be 4%. And when we calculate this, when we use this formula, we will see that the internal rate of return is approximately equal to 4.9%. We have a guess here. Well, we will look into some limitations or some rules that Excel is following when we calculate the internal rate of return. Let's have a look at that in the next part. We have the internal rate of return formula as in Excel. So we have in our case, we have B1 till B4, and then we have the guess. What are the rules that we have to follow? First of all, rule number 1, at least one negative and one positive value. It is clear we have to have a cost which we finish at let's say the project, or investment cost or the project cost, but we also have to have positive values. It means that we are having some return, some profit from our investment. Can we have more than one negative value? Well, it is possible that some of the cash flows will be negative. It depends on the project, because when we start with the production, at the beginning it may be normal that the initial cash flows, the initial profits that we have are negative. So we may have multiple negative values, and we probably will have, or hopefully will have, many positive values. What does Excel do? Excel calculates the internal rate of return by successive estimations. It's a mathematical technique that we can talk about, but basically what they're doing, they're always narrowing the interval until there is a precision of 0.00001%. So when we reach a precision of 0.0001%, Excel will say that we found the internal rate of return. Another element is there are only 20 iterations. If Excel cannot find the internal rate of return with this precision within 20 iterations, it will give an error. It will say we have a numeric error. And that means that we didn't find the exact value with the given precision within those 20 iterations, and then we have to add the guess. We have to add the guess in that case. So we have to understand approximately what internal rate of return we are expecting, and we add it to the formula. This is optional, we don't have to add it, but it depends. When we're far away from the 10% where the iterations start, so that 10% is the first estimate made by Excel. When we're too far away from that 10%, Excel may run out of the number of predefined iterations and will stop. And then we have to add a guess. So that's the principle how we deal with the calculation of the internal rate of return in Excel. Let's have a look at a calculation, a more complex calculations with more cash flows, more different possibilities, and we will see what Excel does and how we can help us to find or narrow down on the expected internal rate of return. So let's now have a look at a more complex exercise completed in Excel. I have here the exercise with an 11-year investment period with an initial investment of 480K, and you see I put there the minus sign. I need the minus sign for later calculations. We have for year 1 25k, year 2 45, 85, 95, 105k, 125k, 100, 85, 80, 70, and in year 11, for example, we sell the project with a remaining value of 50k. First thing what we want to do is to have a kind of estimate of the, let's say, the net present value and an estimate where the net present value will be equal to 0. In this table, I put the percentages. So first of all, I put here 0%. Then I have 2%. I already formatted it as percentage 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22%. What we now have to do is to calculate the net present value for each of these percentages. And we use the NPV formula, NPV. First element we have to put is the rate, which is in the column F. And the rate will change when we copy the formula. Then we have to take the values. We exclude the initial investment. And what's very important is that we put here an absolute reference. So we have to have an absolute reference here, and we do that normally with function F4 and also with function F4. And that's it for the NPV formula. These are the cash flows, and we add the initial investment. And also here we have to put the fixed reference. Now, why do we do a plus here? Because normally we subtract the value from the NPV, from the discounted cash flows, but we already said that the initial investment is a negative value. So that's already very important, and we just enter, and we have the calculation. So when we take the sum of all these elements, we will see that this is exactly what we have. We don't consider the time value of the money. Now we copy-paste this formula, we copy it to all the percentages. What is very important is that we paste formulas here to keep the formatting. And what I see here is that the element that we have here is around 10 and 12%. At 10% we still have a positive value, at 12% we have a negative value. And what we can do now is create a graph. So we insert the graph, we take this type of graph. We can put there a chart title, but what I take out are these values because they don't have any sense here. We put here the chart title, NPV is a function of the percentage. And we find the values here. I can take this away also because we only have one series here. I can improve the numbers here, so I look at format axis. I have a maximum value of 385, so I can say this is 400, and the minimum value is minus 200, which makes the graph a little bit nicer, so we have a clearer view. Here we see the numbers, it's not really nice, so what we do here is format the axis. We look at selection at category number. We want to have the selection on the tick marks, and we also want to put the numbers there. We want to have different numbers. We want to have the percentages here. So what I'm going to do is to select the data. I go to the horizontal category labels, and I select the values that I want to have. These percentages, enter, and we have them. So now we will see that we find the percentages here. We can make it a little bit nicer. We can add the major grid lines, and we see here clearly on the graph between 10 and 12%, we find the intersection with the NPV equal to 0, which tells us that the internal rate of return is between 10 and 12%. We can go further. We can say, okay, we can look at 11% and look at these different elements. Now we know that we can estimate the net present value or the internal rate of return better that it is between. Now we know that we can estimate the net present value or the internal rate of return better, that it is between and 12%, so we can use this as a guess. Do we need it? Well, let's first do it with a guess. And the formula is it's equal to IRR. And now we select all the values, also the negative one. Like I said before, we need to have at least the different elements. We have to have at least one negative and one positive value. And we see that we have an internal rate of return of approximately 10.57%. We can add there the guess, let's say 0.12, and we find the same value. If there would have been a problem, we would have seen here the error, let's say numerical error, and we know that we have to make an estimate, we have to do a quick calculation. We know that Excel is starting from 10% and in fact always finding estimates which are better. There are maximum 20 iterations, and in case Excel doesn't find a value within 0.0001%, close to the net present value is equal to 0, then it will show you an error, and you have to help Excel by giving that guess value. So you have to do some calculations. That was it for this part. So let's go back to the board and I see you there. So you saw the exercise in Excel. It's quite easy to do it. You use Excel, you just put in the formula, and you see that in our case we found the internal rate of return even when we didn't add a guess. Excel is very interesting for this, certainly when you have a very large number of years, cash flows to look at, and it makes all the calculations very simple. It's very important to understand what numbers to add and to follow the rules that I explained just before we started with the exercise. That is all for this video. Thank you very much for watching. Anyway, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.